In this lesson, you will continue to learn how to solve a system of equations using the substitution method. Let's take a look at some examples that better explain this concept. In this first example, we have two equations, which is called a system of equations. In a previous lesson, we would graph these two equations and find their point of intersection, which would be their solution. In this lesson, we're going to use the graphing part just to prove our solution, but we're going to use a different method called the substitution method to solve and find our solution. The substitution method, we just simply substitute in an expression that will help us find our point of intersection. So the first thing you must do is look at both equations and see if one of them is either solved for x or solved for y. Notice the second equation is solved for y, which tells us that y is equal to the expression 2x minus 3, which means they are one and the same and can be substituted for each other. So because y is equal to 2x minus 3, we can actually substitute it in for the y in the first equation. By doing this, we will remove one of the variables, so we only have a single variable and will allow us to solve for that value. So copying down our first equation, if we know that y is equal to 2x minus 3, then the y can be replaced with 2x minus 3. Now when you do this, you need to do it using parentheses. So 5y minus 2x minus 3 equals 0. Now notice, although we have two x's, it's our only variable, so therefore we can simply solve this equation to find the value of x. So we will distribute the negative sign, which is like distributing a negative 1. So negative 1 times 2x is negative 2x. Negative 1 times negative 3 is positive 3. From here, we would combine our like terms. So we would have 3x plus 3 equals 0. We would then subtract 3 from both sides of the equal sign, leaving us with 3x equals negative 3. To finish this, if you divide 3, x equals negative 1, which will be half of our answer. So our solution is an ordered pair because, again, it's the point of intersection if we were to graph these lines. So we now know half of our ordered pair because we found that x is negative 1. Now we want to plug that negative 1 back into the x of one of our two original equations. It's always easiest to use the equation that's already solved for either x or y. In this problem, it would be the second equation, which is y equals 2x minus 3. So now that we know that x is negative 1, we can replace the x with negative 1. And then we simply simplify the right side of the equal sign to find our value of y, which would be negative 5. So our solution is negative 1, negative 5. Now what we're going to do is scroll down and you will see the same two equations again, but you will see a graph this time. And we're going to confirm our answer by graphing the two equations and making sure the solution is in fact negative 1, negative 5. So let's take a look and see what this looks like. So we know our solution is supposed to be negative 1, negative 5, but we're going to graph it to confirm it. But before we can graph, we need to make sure both equations are solved for y. So our first equation, 5x minus y equals 0, is not yet solved for y. Our second equation, however, is. So let's solve our first equation for y. So we will subtract the 5x from both sides, leaving us with negative y equals negative 5x plus 0. To finish isolating the y, we will divide each term by negative 1. So we have y equals 5x plus 0. So if we graph our first equation, the m, or slope, is 5 over 1, and the b is 0. In the second equation, the slope is 2 over 1, and the b is negative 3. So let's scroll down and graph that and see if the point of intersection is at negative 1, negative 5. When we graph our first equation, our y-intercept is 0, and we will go up 5 and to the right 1, or down 5 and to the left 1. Then we will draw our line. Our second equation has a slope of negative 3 and a y-intercept of 2. So we will go up 2 and right 1. And we're going to have to put some points below the y-intercept so we can find the point of intersection. So from the y-intercept, if we go down 2 and left 1, you can see where the point of intersection is going to be. It's going to be right there. But let's go ahead and draw our line. So the question is that point of intersection negative 1, negative 5, like we found when we used the substitution method? And in fact, it is. So we have just proven that our solution was correct using the substitution method by graphing the lines. Let's now take a look at a second example. In the second example, notice that neither equation is solved for y. So we're going to want to solve one of the two equations for y, or x. In fact, in this particular system of equations, the second equation would be very easy to isolate the x. The first equation, you may want to clear the fraction first. So in the first equation, x over 3 minus y equals negative 1. To clear our fraction, we would want to multiply all the terms by the denominator of that fraction. So the 3's would cancel, leaving us with x minus 3y equals negative 3. And this will be easier to use as we go through the substitution process. So let me go ahead and star that equation. If we then look at the second equation, which is x minus 4y equals negative 3, we're going to want to solve that equation for x, or isolate the x. So we can add 4y to both sides. So we would have x equals the expression 4y minus 3. So let me go ahead and box the first equation that we cleared the fractions for, and then the second equation that we solved for x, because that is really what we're going to want to use for our new system of equations as we go through the substitution process. So because x is equal to the expression 4x minus 3, we can plug that into the x in the first equation because they are equal. And when we do that, it will eliminate the x's in the first equation, leaving us with only y's. So let's go ahead and do that to the right of the line. So instead of the x, in parentheses, we're going to put 4y minus 3 because it has the same value as x because they are equal. We will then drop down or bring over the minus 3y equals negative 3 from that first equation in the box. So take a look at that for a moment and make sure you understand what was done. Now to solve this equation for y, notice when you look at the parentheses, there isn't anything in front of the parentheses to distribute. So you can simply remove the parentheses for this problem and then drop everything else down. We then need to look for like terms, which we have 4y minus 3y, and that equals y. So we'll drop down the minus 3 equals negative 3. We will then add 3 to both sides of the equal sign, leaving us with y equals 0. So we now know half of our answer. From here, we need to plug in the 0 for y in one of our two equations, either original equations or the ones that I boxed to the left. I would use the second equation boxed on the left that's already solved for x, which would be 4 times 0, since we now know that y is 0, minus 3. When we simplify this, y equals 0 minus 3, x equals 0 minus 3, we get an x value of negative 3, which we can then put back up in our ordered pair for our solution. So our ordered pair or solution would be negative 3, 0. Now we're going to go ahead and scroll down and graph these two equations to see whether or not, in fact, negative 3, 0 is the solution. Okay, so our goal is to see whether or not the solution for the second system of equations is negative 3, 0. So we need to graph these two equations. But first, we must solve them both for y so that we can identify their slope and y-intercept in order to graph them. So let's write both equations down and then solve them for y. For the first equation, again, you may want to start by clearing the fraction and multiplying all terms by 3. This would give you x minus 3y equals negative 3. You would then isolate the y by moving the x over, leaving us with negative 3y equals negative x minus 3, and then divide all terms by negative 3. So the equation solved for y would be y equals, let's put a 1 in front of the x, the double negative, negative divided by negative would be a positive 1/3, which is our slope, and our y-intercept, negative 3 divided by negative 3, is a positive 1. So in a moment, we will go ahead and graph that information. For the second equation, we also need to solve it for y. So we will subtract x from both sides. So we have negative 4y equals negative x minus 3. We will then divide all terms by negative 4. So we have y equals 1/4 x. And again, for the 3 and the 4, although we cannot divide them, the negative divided by a negative will change it to a positive 3/4. So let's scroll down and graph these two equations and see if their point of intersection is in fact negative 3, 0. If we graph the first equation, our y-intercept is 1 and the slope is 1/3. So we will go up 1 and right 3, down 1 and left 3. And we can draw our line. Now this is a little bit tricky because our y-intercept in our second equation is a fraction. But you will see how this works once we find the point of intersection. So to graph 3/4, 3/4 is just below 1 on the y-axis. So it's hard to draw, but it's just below 1. So then when we use the slope, we will go up 1. So now we'll be at 1 3/4, and then over 3. Over 4. So the point will be approximately where you see in red. Then we will go down 1 and over 4. And notice the third red point. Now it's hard to see, but when you graph, or when you actually draw the line and connect those, your line will be cutting right through the point at negative 3, 0, which is in fact the point of intersection. So we just confirmed that our point of intersection that we got using the substitution method is the same as what we got by graphing. Let's do one more example showing the substitution method and then proving using graphing. In the third example, we again have a fraction that we need to clear, and then we want to solve one of the two equations for x or y. Although the second equation is already solved for x, if you're not comfortable with the fraction, you may want to go ahead and clear it and solve the first equation for y instead, since its coefficient is 1. That makes the process easier. So let's start with the first equation and solved that equation for y. So we would subtract 2x from both sides, and y equals negative 2x plus 8. So this would be one of the two equations we'll use as we go through the substitution process. In the second equation, x equals 1/2 y minus 4. Again, you may want to clear the fraction to make the problem a little bit easier to solve. So we would have 2x, and the 2's would cancel, so equals y minus 8. Now don't divide everything by 2, because then you'll be right back to where you started from. So just leave that if you want, or if you're not comfortable with that, move the y to the other side by subtracting it. So it'd be 2x minus y equals negative 8, which would be the second equation we're going to use. Now, going back to this first equation that is starred, we now know that y equals the expression negative 2x plus 8. So in our other equation, we can replace the y with negative 2x plus 8 because they are equal. So let's go ahead and do that on the right side of the line that was just drawn. So copying down the bottom equation, 2x minus y equals negative 8. Again, we're going to replace the y with our boxed expression, 2x plus 8. So now we will have 2x minus, and remember, when you substitute in the expression, use parentheses. We will then distribute our negative, or negative 1. So we have 2x plus 2x minus 8 equals negative 8. We can combine our like terms and get 4x, and then we can add 8 to both sides to get our like terms together as well on the right, leaving us with 0, because negative 8 plus 8 is 0. Divide 4, and x equals 0, which will be half of our answer. So now we can take one of our starred equations or one of our original equations and plug 0 in for the x. So it'll be easier to go back to that first starred equation that is solved for y, which was y equals negative 2x plus 8. We can now replace the x with 0 because we know the x is 0, and then simplify the right side of the equal sign. So 0 plus 8, which leaves us with a y value of 8. So 0, 8 should be the point of intersection if we were to graph these two equations. So let's go ahead and scroll down, and we will solve both equations for y. Then we will graph them and see if its solution is 0, 8. Now notice, before we scroll down, I'm going to use a green pen, that first starred equation is already solved for y. So you can just simply use that, and we will transfer that information down when we scroll down. The second equation, we've already cleared the fraction. So again, when you transfer your information down, you may want to transfer those two equations and start the process of solving for y from there. So let's go ahead and do that. The first equation is already solved for y, so we can identify m and b very easily. So m is negative 2 over 1, which is our slope, and our y-intercept would be 8. In the second equation, we need to solve for y. So we will first move the x term to the right. Then we will get rid of our negative in front of the y by changing the signs of all three terms, which is the equivalent of dividing all terms by negative 1. So now we can identify the slope of 2, or 2 over 1, and the y-intercept of 8. So let's go ahead and scroll down to the graph and graph this information to find the point of intersection. Now recall that we want our solution to be 0, 8. So let's see. Our first equation, we'll use this information to graph. So 0, 8 is our y-intercept. So way up here. Our slope is -2, 1. So let's go down 2 and to the right 1. Down 2 and to the right 1. Showing a line going down, which means it has a negative slope. And then we will graph our line. For the second equation, again, our y-intercept is 0, 8. So you can tell that that's the point where they will intersect because they both share that point in common. For the second equation, the slope is +2, 1. Since we don't have enough graph to go up 2, right 1, we will reverse both directions, and instead of going up and right, we will go down and left. But the line, once we connect all points, will go in a upward direction, which means it has a positive slope. So our point of intersection is in fact 0, 8. So we have confirmed that the answer we got using the substitution method is correct. And this completes the lesson on solving a system of equations using the substitution method.